Hey there, geometry. I'm trying to find a cool place on this summer day, and the only spot I could find is my front porch. It's a little noisy, but I think we can get through this, okay? We're going to do section 4 of chapter 9. It's called Inscribed Angles. And let's talk about what an inscribed angle is, okay? So if you have a circle and you have this angle, then this is called an inscribed angle. I forgot what this is called. This is called an intercepted arc. This part over here is the intercepted arc of the angle. So first of all, it's theorem 9.6. And it says that an inscribed angle, the measure of that angle equals 1/2 the measure of that intercepted arc. So if I told you this angle was, I don't know, 25 degrees, then what's the measure of that arc? Well, you should know that it's twice that now, it's 50 degrees. Or vice versa. If I told you this was 90 degrees, then you know that this is going to be 45 degrees. Okay? So, actually, sorry, I don't know if you call this degrees. If this is 45 degrees, this is 90. That's the measure of that. All right. Theorem 9.7. Let's say we had the same intercepted arc out here. And we had two angles that intercept that arc. So we've got this angle here and this angle here. And do you see they have the same exact intercepted arc? Well, theorem 9.7 says if you have two angles having the same intercepted arc, then these two angles are congruent. And I think you see, I mean, it makes sense, right? If we know that this is the same one and these are both half of that, then they're both going to be the same. All right, moving on. This is theorem 9.8. When you start having polygons inscribed on a circle, there starts to be some special cases. So let's say that you had the diameter of a circle, and you had a triangle that when it was inscribed there, its sides perfectly matched up with that diameter. Well, what do you know about this angle right here? Well, if you just a moment's thought, I think you can see that we already talked about well, this is going to be half the circle, right? So this distance is going to be 180, I guess it is degrees. It's 180 degrees. Well, if you know that that arc is half of that, I mean, if you know this angle is half of that, then you know this is going to be a right angle. No matter where I put this triangle, if it matches up perfectly with the diameter of that circle, then it's going to be a right triangle. If we did a if we did a quadrilateral, this is 9.9. So make a circle and put any old kind of quadrilateral you want. Well, what can you tell me about, for instance, this angle and this angle? I think if you think about it for a second, something will become very apparent. Look at this angle. It carves out this arc here, right? And this angle carves out this arc here. So together they carve out 360 degrees. So you know that these are going to be half of that 360 degrees. So this, let's call this angle A, B, C, and D. Angle A plus angle C equals half of that 360 degrees, so it equals 180 degrees. In other words, they're supplementary. If you do the same exact thing with this angle and this angle, you can see that it's going to carve out to here, this arc, and it's going to carve out this arc. Again, it's going to be 180 degrees. So angle B plus angle D equal 180 degrees. All right? Okay, I think that is it. We go through theorem 9-9. And of course, there's a bunch of practice, but that is it for this section of chapter 9. Okay? All right, I'm going to go back to cooling off.